prove that at some time during the race they have the same speed. Oh, okay. So this what is this? They give you a hint. What does this function represent? If G and H are the position functions, what does that F function represent? Distance. True. Be a little more specific.
As a rate of time.
Distance between what?
Oh, the two runners.
There. Okay.
Yeah.
Yeah. It's how far apart the two runners are at any time. Right. So why does this? I really want this to kind of make sense. You could think about it just generally. If they start running and one guy's running faster than the other one, yes? Then at some point, if they finish the race at the same time, they finish in a tie, right? Doesn't the other runner have to speed up to catch up to him? So while he's speeding up, isn't that velocity going to be the same as the other runner? Okay, so that's conceptually makes sense. Now you got to figure out, well, how do I show that mathematically? Okay, so I want to make sure everybody understands the groundwork for that. I mean, conceptually it makes sense. So, are the position, what is this function at the beginning of the race? What's the value of this function at the beginning?
0.
0. What's the value of the function at the end?
Whatever the race was. No, wait, it's 0. Because
0. So, what does Rolle's theorem say?
That
They're continuous, right? Neither one is going to teleport that I know of. We're going to assume that these are normal people. This is not a sci-fi problem, right? Okay. Yes.
that both functions are continuous, that they have to
Yeah, that's what we're not really assuming. We just know they have to be continuous functions, correct? They have to be differentiable, right? Otherwise, you'd have to say, I don't know what the speed is at this time because he blipped out of his. No, can't do that. I really want. I mean, all right. I'm always at a point where I'm like, if I say one more thing, you've got the answer. So looking at F, doesn't it start at 0? Doesn't it end at 0? Now, all Rolle's theorem says it's got to start and end at the same place. That function happens too. And it's continuous and differentiable. So look up what Rolle's theorem says must be true and try to figure out what that means physically for this problem. All right. Hopefully it's enough to at least consider what to do. You feel, is that more than you knew when you first asked the question?
Yes.
Okay. Okay. You know what the answer is? No, but that's fine. That's the whole point. Anything else from homework stuff or? You guys see the note on the board? So we got a quiz on Monday. Yeah.
4373.
Oh yeah, okay, this is good timing. Somebody else has asked me about this one. Okay, listen. All right. What's a better way to write this right here? What is there's two meanings to this. It has a local maximum, so what does that relate to? Local maximum, does it relate to the function? Does it relate to it relates to the derivative. I like it. So what must the derivative be at x equal -2 if there's going to be a maximum there? 0. And we know it's a polynomial. It's not going to be undefined anywhere, so you can kind of let go of that possibility. So it must be 0. The derivative must be 0 at x equals -2. Don't let go of that, though, right? What else does this tell you? What's true about the function? What must it do? According to this right here. What must the function do?
Go to 3.
When you put a -2 in. So when you put a -2 into the function, the output has to be 3. Isn't that 2 pieces of information so far?
Good.
Couldn't you get the same 2 from this other thing it tells me?
Now you know what D equals.
Maybe. How many unknowns are there?
4.
How much information do you need?
4.
So am I not going to get a pair of equations from the max information, a pair from the min information, system of equations? If anyone really wants to, you could set up a matrix to solve it. Row reduce. Right? That would be what I would do, but I'm weird. Or you can just remember how systems of equations work. You got to kill a letter multiple times and then kill another letter multiple times. I don't know if you guys remember how that works. Maybe? You guys, all right, real quick. Bum, bum, bum. Okay, let's do, if I had this, how would I solve that? What would I do? First step. Say again, sorry? All right, cool. You could solve the first equation for C and then replace this C with that. Why would that be good? What's the problem with all of these equations? What's the problem? Why can't you solve any of the equations by themselves? Freaking too many variables, right? Number of variables. It's too damn high. Okay. So one way I can kill a variable is by elimination. Just straight up, if I added the first and the third, don't the C's die? But I like Aldo. He says, no, I want to be more subversive. I don't want to just directly kill them. I just want to come in like Invasion of the Body Snatchers and replace them, right? So he says, solve the first one for C. Isn't there going to be A, B shit over here now if I solve it for C? Then if I replace each of these, don't each of these now only have 2 variables? I like that. That works. And then once you have 2 equations with 2 variables, you guys better know how the freak to do that. And if you don't, just see me afterwards. But all right. Maybe. So real quick. So you could solve this for C. Then you could plug this in there. Plug it in here. What is it? There I am. Right, so plug that in there, plug that in there. Now I have 2 equations with 2 unknowns. Distribute, get like terms together. Now kill B or kill A, right? Is that all right? Now, of course, you guys are saying, but I have 4 letters in mind, Jeff. Not really. Don't 2 of them not have, 2 of them won't have D in them. So you've already kind of started. Yes? Oh, okay, real quick. So let's look at let me pick 2. Sure, let me pick the first 2. All right, stay with me now. So I'm claiming you can just add these together. So I'm claiming you can do this. Right? Is everybody cool with me doing that? Do you guys remember why I'm allowed to? What are you supposed to add to both sides of an equation? The same thing, correct? So does anybody have any... I know you've seen this before. Do you really understand why I'm allowed to do it?
Yeah.
Okay. Tell me.
The 3 equals that on the side, so you're basically just adding 1 to both sides.
Well, you're adding
You're
3 to both sides. So like,
yeah.
let me say this one. What is A plus B plus C? It is 2.
Yeah.
So if I add 2 to this side, I'm going to add 2 to this side. Does that make sense? You got to add the same thing to both sides. Didn't I just add 2 to both sides to get here? Didn't I? Didn't I? Because isn't A plus B plus C, isn't it 2? So if I add 2 to this side, I better add 2 to this side. So that's why you can take any equations anywhere and add them. Now, of course, you want to be smart about which equations you add, because what's really good about what I just did, I killed B. Right? I like this because you can get some frustration out about math. You can actually just directly kill. You're like, suck you freaking little variable, die. I don't know. I have no idea if you guys have any math frustration you want to get out. You can just kill a letter. Okay. Sorry. My math is a little Game of Thrones-ish. Pre-season 8. All right. Maybe season 8, to be honest. Okay. I don't know if you guys watched it.
Not the best writing.
What's up?
Not the best writing the math revenge for.
Well, yeah, let's not get into it. I could have a whole semester class on what they did wrong in season 8. Anything else from homework stuff? Okay. So, we need to do a couple things. So just to make sure you guys have quiz on Monday. The question I'm going to have from section 4.3 is going to be kind of very direct. It's not going to be anything. It's just going to be, are you able to find critical numbers and all that kind of stuff? It's going to be very basic. You with me? Because obviously those can get really disgusting. But it's going to be really basic. Just do you understand all the steps involved? Okay. So last time we worked on a handout that I have completely hidden from myself. There we go. We did this side last time. And inherent in this was an asymptote, right? And somebody pointed out to me that there are some asymptotic stuff in section 4.3. But let me show you this real quick for anybody who doesn't like looking at their book. It kind of goes through everything, and you can kind of follow. I basically ask you most of these questions, A, B, C, D, E, F, G, whatever, right? As I take you through one of these. The one that I don't normally ask is symmetry, because it's not too often that we even think to look at the symmetry, but sometimes the symmetry might help us do things. In fact, I don't know if anybody remembers doing, I brought this up before, but nobody remembers. Do you guys remember polar coordinates? Cardioid, the cardioid, otherwise known as the butt graph, affectionately. You guys don't remember any of that shit. All right. Does anyone remember that? Right, where you had something that looks like this? No?
You made that up.
Yeah.
I totally did. You're on to me. All right, this is a little bit concerning. That's a huge part of pre-calculus is polar coordinates. You guys, you got to remember polar coordinates, right? Where x is r cosine theta, y is r sine theta. Theta is inverse tangent of y over x. Does that look familiar?
Yeah.
So if I give you a polar equation, this is one possible output. So you look at all the anyway, I'm not gonna teach you polar coordinates right now. Okay. We will be talking about polar coordinates later, and then I will review them. And you'll see what equation leads to the butt graph. But all right, so let's look at this thing real quick. We're going to basically do this one together because we got a lot to get through. You guys can do this though. Oh, sorry.
I wasn't here.
Oh yeah. Anybody else need this? Yeah. So we did number 2 on this last time. Tell me, what's the domain of this thing? Yeah, x not equal to 1. Right? If you want to be all technical, negative infinity up to 1, 1 to infinity, but who gives a shit? Those both say the same thing. I like it. All right, let's do this derivative. Okay, so obviously I need some more paper to do this. Oh my god. I had a ton of paper here. Where did it all go? There it is. Okay. I got to tell you something. I'm not used to teaching on the overhead. I don't know if you guys have picked up on that. So I am not used to having to use so much freaking paper. Okay. So obviously what I have to do this derivative? Yeah. I mean, I could do prime. Let's just do quadrant. So can we kind of speed through this a little bit? What do I take the derivative of first? The top one. So that's just this, right? Is that cool? Times the bottom. Keep going for me. All right, so the derivative of the top times the bottom minus the top times the derivative of the bottom all over bottom squared. Okay, not too bad. This is always exciting for me, by the way, because I'm like, did I do this right when I made this? Well, let's find out. So now I get negative 2x squared. Is that cool? Minus 16x. Oh, I forgot my... Oh, screw it, Jeff. It doesn't. Keep going. Plus 4x squared. Plus 16x. Minus 4x. Minus 16. Just to write too much. Okay. I don't know why I did those out of order. Who cares? Cool. All right, so I just chose to put the second one first because I'm weird. So then I get 2x squared minus 20x. What happened? Oh, there's another 16. Thank you. I was going to write the plus 16, but that you could put those together, Jeff. Minus 4x minus 16 all over x minus 1 squared. So we got to the answer one step quicker thanks to you. Yay! All right, not too bad. And again, just in case you have trouble with this, let it go, finish the problem, come back to it later, right? Okay. So that's verified. Is everybody cool with that? Okay, I like it. How do I find the critical numbers of this? I mean, what's the most obvious critical number? 1, because that's where it's undefined. But is 1 in the domain? No. Yeah. Yeah. Good.
Negative 1?
What, negative 1 why?
Would that be a critical number? Because you have x minus 1 squared in the denominator, which simplifies out to x plus 1, x minus 1.
Careful now. What's the square mean? You have two of the same thing, right? So on the bottom would be x minus 1, x minus 1.
Oh, okay.
Okay. I understand, though, because the difference of squares gets stuck in your brain when you see a square. But that means 2x minus 1s. Okay. What else? There's 2 more critical numbers. How do I get them? Yeah, the only way that this derivative could equal 0 is if the top was 0. And thankfully, this will factor, so you don't have to use quadratic formula. Although some of you will anyway. Right? I can kill a 2, right? Please, dear God, don't use frickin' quadratic formula in this shit. Yeah. So my other 2 critical numbers are 4 and negative 2. I like it. Alright, so when I go to make a sign diagram, I got my negative 2, I got my 1, I got my 4, undefined, and zeros here. Okay, let me slow down for a second. I go ahead and put 1 down there because that's undefined. It's still a place where it could change from increasing to decreasing or something, right? For example, think about, something like this. It's increasing on one side and decreasing on the other side, but it's undefined between those two. So it should still show up on your sign diagram. All right, let's see if we could do this. Okay. The only critical number that comes from something that wasn't an odd multiplicity is 1. So it actually ends up being the same sign on either side of 1. The other two came from multiplicity 1 stuff. Okay, so if you understand multiplicities, this will be a little bit quicker. If you don't, who gives a shit? You just plug stuff in and figure out what the sign is in each area. So if I plug a 0 in, I always try to do 0. What's the derivative at 0? Is it negative or positive? The bottom's always positive, and the top is negative, so it's negative. And then you could plug a 2 in, or you could just say, okay, multiplicity 2 around 1, so it's going to stay the same sign. It's going to change signs over there. It's going to change signs over there. And again, you could plug a 5 in. You could plug a negative 4 in. Right? Get the same information. Multiplicity just makes it a little bit quicker. So again, I really want you to understand, if you don't really understand multiplicity, that's a little bad, but you can still do the problem. Okay. All right, so what does it look like in terms of increasing, decreasing? Where's it increasing?
And from 4 to positive.
I like it. And can I just say, you guys know the answer. You guys know what I'm going to ask you, don't you? Does anyone know what I'm about to ask you? Can I just put 1 interval for decreasing?
No.
Hell no, because at 1, it's freaky. So I got to do negative 2 to 1, union with 1 to 4. So is there a local max?
Yes.
Where?
-2.
Negative 2. I like it because it goes up, rests, comes down, rests, goes down, and then up. And that's really gross, but who gives a shit? So there's a max here and a min there, and a little resty spot. A little resty spot right there. How do I figure out? I'm still going to get somebody who puts that in here and gets 0. Of course it's 0 when I put a negative 2 in, because that's where the negative 2 came from, making the derivative 0. What do I want to put negative 2? I want to put it in the function to figure out what the function is. Yeah.
8.
Is it 8? Cool. Thank you. And then the min is there for something. 32?
Yes.
Yes? Finally, I've created one that's got a more interesting scale. Okay. All right, now, I've said this before. Well, I don't even really have to say this, I don't think. I'm not even going to say it. Screw it. How am I going to show? What I was about to say is I am going to start taking a derivative with the non-factored form, right? Because if I do the factored form, it's going to be product rule inside of quotient rule and shit. But if I just do this, it's just a straight up quotient rule, right? Okay. So let's verify this second derivative real quick. So it's going to be derivative of the top times the bottom. That's exciting. Minus the top times the derivative of the bottom. Let me stop for a minute. All over. What's going to be on the bottom? Fourth power, I love it, because you square it's already there. Does anyone see something I can automatically do?
Come on, next time.
Yeah, I can kill. I really want everybody to see this, right? The only way I can cancel something is if it's in all terms. Every term has an x minus 1, at least one. So I can kill an x minus 1 everywhere. Is that cool? Okay. That's nice. I got less freaking multiplication to do. And there's another x minus 1 here, but this guy, we factored him. How did he yeah, there was no x minus, that's right. So now I've got 4x squared minus 4x minus 4x minus 8x plus 4 minus, is everybody, just multiply this out. And then I'm just going to double this and change all the signs. 4x squared plus 8x plus 32 all over. I just know I'm going to make a mistake somewhere, so somebody keep an eye on me. Well, it looks good. Let me take a peek. Yeah, Jeff, you did good. So these die. These die. 36 over x minus 1 cubed, which is what it is. Yay. That's kind of big, though, this step right here. Wouldn't that have sucked if I didn't notice that? I'd have so much more multiplying to do. Yeah.
Did you get the second 4x squared?
This guy? Right here.
Oh, wait.
Okay. Yeah, that was the derivative of the bottom right there, right? Okay. All right. And what are the, what's this?
None.
Well, there's sort of one, but it's not even in the domain, but we'll still say it. X equals a 1, so it's undefined there. But again, it's got to be on my sign diagram, right? There was a problem earlier that 2 was not in our domain, but it was at the end. So it really didn't matter. It wouldn't be in the middle of our sign diagram. Hold on.
I like your beard.
Say again?
I like your beard.
You like my beard? Okay. My beard likes you. Aw. So now I need to do this. I've got the one thing I can put here. And this will show you, so I'm kind of happy I did this example because, again, I really want you to understand. Do you guys remember that one problem where 2 was not in the function? It was one of the earlier ones we did. Yeah, here. 2 wasn't even in the domain, but it was at the end. So it didn't really, but I still put it on my sign diagram and sort of told myself there's a wall there, so it sort of doesn't matter. Why does this one matter? Because it's in the middle of everything. It's undefined, but around it, the concavity can change. It can go from concave down to concave up. So it still has to show up on your sign diagram. Put a little U above it so you know it's freaky there. And of course, what happens, like if I put a 2 in, yeah, this is positive, and on the other side it's negative. So where's it concave down?
On the left.
I like it. And where's it cup up? That's crazy. So is there an inflection point? Yep. Yeah, 1 undefined. Right? So there's an inflection point. So here's, and again, I really want you to understand, I'm still going to put this down at x equals to 1. So the most basic function we see where this happens is this. What is this the graph of? 1 over x. What's the concavity here? Down. What's the concavity here? Up. But it's undefined here, yes? So undefined is still a place where it could change concavities. In fact, isn't it decreasing here? Well, it's decreasing there too. That's a bad example, but it could have been like this, yes, and it could be increasing. So it could even be a position where it goes from decreasing to increasing across an undefined. Okay, I like it. All right. So the one new thing here, the one little new thing is, well, first off, somebody tell me, where's the vertical asymptote? We kind of know. We've seen it all the way through all our work. Where the hell is the vertical asymptote? X equal to 1. Yes. That's where everything gets really freaky. Is everybody with me so far? Is that cool? Yes?
Can you remind me why inflection point or X?
Oh, what's inflection point mean? It is where the what changes.
Second derivative.
Sure, so where the second derivative goes from positive to negative or negative to positive. So it's where the concavity changes.
Oh.
Yeah, that's all it is. What could be happening at that point is anything. The definition doesn't give a shit. It's like around 1, it was cupped down, and now it's cupped up. So that is an inflection point. It's not really, so here's the deal though. It's not really a point, but it's still information for when I'm graphing. I know if it's cupped down on one side, it's got to be cupped up the other side. But it's not a point that we can graph. So in that respect, I agree with you. It's not really a point. Okay. What's the other kind of asymptote that we could have? Horizontal. Is this officially a horizontal asymptote situation?
No.
Why not?
No. I remember how to find them. I just don't remember what it's.
So remember the three situations.
Higher than the bottom.
Yes. The three situations. If the bottom power is higher than the top, it goes to zeros. Asymptote at 0.
Yeah.
If they're the same degree, it's the ratio. So there's going to be a horizontal asymptote somewhere. If the top degree is higher, the whole thing goes to infinity, but it goes to infinity following a slant asymptote. Does that, or oblique? I don't know what your teacher said. Do either of those sound familiar? Slant asymptote, oblique asymptote. Oblique. Okay. How the hell do I find the slant asymptote? What I do is, say again? You do what it says. Yeah. Now I could do this, or I could do synthetic, right? Let's do synthetic, just so we remember. Because I don't know, we should all agree that this sucks. Can I always do synthetic? Why does synthetic work here? Because the bottom is linear. If the bottom was x squared plus 1 or something, I could not do synthetic. I could. I'd have to use I and negative I, so we probably wouldn't want to. Anyway, sorry. All right, too much shit. So let's do synthetic. How do I set up the synthetic? What do I put here?
I'm sorry, but you're out of your mind.
I totally forget how to do something.
All right. Sorry?
You have to bring the 2 down.
This is true. All right, let's do this. You guys have brought this on yourself. We're going to do long division. There we go. Don't boo, because it's your own damn fault. All right.
Probably better this one.
X times what? That's fine. It's fine. There's not a damn. If you liked long division better, there's a little. I got a little tear. I'm like, oh, that's so nice. There's nothing wrong with that. All right. X times what is 2x squared? 2x. 2x times x is 2x squared. Holy shit. 2x times negative 1 is minus 2x. And then I have to change the signs, as always. So long division does not change. It doesn't. Long division doesn't give a shit if it's a bunch of variables or a bunch of numbers. It always does the same thing. These cancel like they're supposed to. 18x plus 0. X times what is 18x? Holy shit. 18 times x is 18x. 18 times negative 1 is negative 18. Change the signs. So how do I write this at the end? I don't know what you guys said, but I'm going to pretend like you said that. Okay. I got a special place in my heart. It's some place a big R. 18. Remainder 8. No, okay. Sorry. Now, let me zoom out a little bit, real quick, just to show you. Here's what the synthetic would look like. Synthetic says, is this shit necessary right here? Aren't those always going to die?
Yeah.
So they don't mean shit. So what synthetic does is it says, okay, let me just keep track of the most important stuff. 2 comes down. Why does that make sense? Because why did we put a 2 here? Because there was a 2 there, right? And synthetic is built on this being a 1. So that's why that just comes down. This could be a part of the answer. We know that's going to be a part of the answer. 1 times 2 is 2. Add. Am I not right here? Yes? 1 times 18 is 18. Add. Am I not right here? So then this, how do I read this? This was x squared, so this is x. This is 2x. Go down a degree. Go down a degree. Same answer. Okay, I like it. I was going to say something else. I forgot. Oh, well, too bad. Damn it. Oh, yeah. Real quick. Do you remember how we had to change the signs each time we did this? And that's really easy to forget. Look what synthetic does. It changes the sign at the beginning, so I don't have to remember to do it each damn time. I don't know if you understand that. I love synthetic division. Okay. It's a beautiful shortcut. All right. So, what the shit? So now we got the answer. How does this relate to what I want? Well, what happens when x gets really, really big? Because that's what horizontal asymptotes are about. What happens when x gets really big? What happens to this piece? Goes to 0. So when x gets really big, the function looks like this. So that's the horizontal asymptote that it has to follow. Okay. So the horizontal asymptote is y equals 2x plus 18. It's not horizontal, though. Slant. Thank you. All right. So now comes the great. Oh, let's finish this up before we graph anything. Intercepts. How to find the intercepts of this function? How do I find the y-intercept? Make x 0, so I get 0. So there's an intercept at 0, 0. There's one more intercept. What's the other way? So make x 0, find the y-intercept. So how do I find the x-intercepts? Yeah, make the function 0. The only way the function can be 0 is if this is 0. And then I can factor this thing. So it looks like there's an intercept at -8. So -8, 0. There's 2 intercepts. Okay. So you can tell I can't give you like 5 of these on a test, right? Because that would be like, holy shit, I need 2 more days. Okay. So let's plot everything. There are a couple things I could plot. Can we figure out what the x scale should be? So, say again?
Oh, the x scale?
X scale. Yeah, look how everything, this is all my x locations of important things are multiples of 2, right? And I got to get up to 8, so it kind of looks to make sense. And that's how we determine it. You say, what's all the x pieces that I have to display? And look at the highest ones, of course, and the lowest ones to make sure your scale fits everything. So a scale of 2 looks to make some sense. So let's do this by 2. And then what about my y scale? What should it be? What's the highest I've got to get on my y? 30, freaking 2. And what's the lowest I got to get?
8.
Yeah, it looks to be 8. 0 really, but yeah, all right. So it looks like, what can I make that scale maybe?
8.
Yeah, let's try to make that scale 8. I think that'll work fine. Let's see. Yes. Yes. Yes, okay. So let's see. 8, 16, 24, 32. Woohoo! And then this down here doesn't really matter. I'm just going to do a couple of these. Okay. All right. Here we go. Here we go. Here we go. So now we got everything. So now I can just, I always start with my intercepts because those are my anchor points. All right, then you can do, it doesn't matter from here. I could do my vertical asymptote is at 1. My slant asymptote is 2x plus 18. All right, so we're just going to have to kind of estimate this a little bit. So there looks to be about 18, somewhere in there. Is everybody with me? 2x plus 18, so the y-intercept 18. And then I want to go, all right, so it's 2 over 1. So it's 4 over 2. It doesn't matter. I really hope you. So right, the slope is 2 over 1. So let me go up 4 over 2. All right. And you could do that several times if you want to. So there's my slant asymptote. Could the slant asymptote be nonlinear? Yes, it totally can be. Right? Why was this one linear? Because what's the difference in the degrees between the top and bottom? Just 1. So if the top had been cubed and the bottom x, I would have gotten a parabolic asymptote. Oh, yeah. Sorry. All right. Oh, you guys are loving everything. Okay. So let's put in what we know. We know the max. There's a max at -2, 8. So I can kind of see what that's doing. That's kind of nice. Right? There's a max here. You should be doing this in different colors, Jeff. That's too bad. I don't even know if this is going to show up. Does everybody see that? There's a max there. It's kind of nice. So I see exactly what it's doing. It's going to be on this side, obviously, right? And then where's my min? 432. So 432. There's a min. That's, I mean, this is, I don't know if you guys remember doing this in pre-calc. Anybody? And the only real inflection location, we're not going to call it a point, is around the vertical asymptote. Right? Yes?
What is the point you graphed at
X equals 2? Oh,
on the graph?
this one?
Yeah.
Oh, okay. That was just to get the other point for the slant asymptote.
Oh, so
Y-intercept 18, and then I went up 4 over 2. Just so I can get that slant, yeah. Okay. Y'all with me so far? Yes?
Why is the min at 4 higher than the max at -2?
Is it a local max or min, or is it an absolute max or min? Local. Yes? So in a mountain range, can there be a valley that's higher than the top of a mountain?
Yeah.
Yes. Isn't this valley taller than this peak?
Yeah.
So can you see how this is going to look? Isn't this going to look like this? It isn't going to look like this. So locally, this is the max. Locally, this is the min. You guys with me? So local just means it has no idea what's happening anywhere except in a little neighborhood around that point. So in a little neighborhood around that point, it is the king. It wins whatever that contest is. Yes?
So for the slope asymptote, you said you can go up 4 instead of
up 2 over 1, but I went up 4 over 2.
Oh.
Just so it could be on a... it truly doesn't matter. Yeah. All right. So now I basically have everything I need. What is it? What's the concavity back here, which definitely makes sense with how things are working. So it goes like this. Concave down all the way through. And I got to slam up again. Well, shit and a half, Jeff. What have I done wrong here? Anybody notice?
Away from that.
Yeah, it should really be hugging that asymptote. Right? And then what happens here? Concave up. And it's got to follow that asymptote and then follow this asymptote. Cup up, cup down. Crazy shit. And this is when you would first look at it in your graphing calculator, right? And you only change anything if there's something majorly wrong. And you go back and make sure you can find out what you did wrong with your math. If you can't figure out what you did wrong with your math, leave your graph alone, right? Don't change your graph and have it not match your math, because that's when you're going to lose the most points. Okay. Okay. So that's basically 4, 3, 4, 5. 4, 4 was L'Hopital's rule, so I need to wait till you guys try those out. We're going to do a little bit of 4, 7. 4, 6 I don't think I put in the... It's not part of our stuff, I don't think, if I remember correctly. So if there's no questions on this, we're going to get into section 4.7. Okay. I know you guys are going to be excited about this. Did we have a section that was already like calculus word problems? Yes? Yeah, it was the related rate stuff, right?
Yeah.
All right. That was not enough calculus word problems, right?
Oh boy.
Yeah, I know how to sell stuff, man. I'll tell you what. All right. So yes, indeed. 4.7 is optimization. All right. What I want to do is, I want to kind of remind you guys of a problem you should have done in pre-calculus. Let's say that I have a garden, and let's say I want the perimeter to be, what do you got, Jeff? Sure, let's just make this easy. I want the perimeter to be 40 square feet. Get out of there, square. All right, sorry, I'm thinking ahead. So I want the perimeter to be 40 feet. I got 40 feet of fencing for my garden, right? Hopefully at least one person here knows what the answer is going to be without any work, but we're going to do the work anyway. I want to maximize the area, right? And why does it make sense that there would be a maximum area? Couldn't I make this garden, you could do this, Jeff. You could really do this. 19 by 1, 19 by 1. Doesn't that use 40 feet of fencing?
Yeah.
Do you think this is the maximum area I could have? Hell no, right? So somewhere there's a sweet spot.
100.
Square feet.
Yeah, we're going to get there. How do you know that?
Because it's like square.
Yes. All right. So one thing I hope some of y'all picked up on is if I just have a four-sided rectangular figure and I want to maximize the area, it's always a square is the answer. I like it. And side note, what shape are most silos in? Silos, you guys know silos that hold peanuts and corn? Say again?
They're cylindrical.
Cylindrical. So the real maximizing shape is a circle if you're packing it with stuff that's not itself like rectangular, like little beads, little corn, little peanuts, whatever, right? Why aren't trucks circular? Because we pack them with little cubes. So it should have sides. That makes more sense. Are you guys semi with me? Anyway, sorry. That was so... I have a shirt that I'm wearing that actually says, I go off on a tangent, and of course it's got a tangent line kind of picture. All right, I'm sorry. So here's what they tell me. Ooh, this sounds familiar. Here's what they tell me. And they ask me to maximize the area. Whoops. So we've sort of already gotten some practice at this because you figure out your variables. So what do you want to call this side? I love you. So we'll call it y. And this side, of course, will be x. You can call them whatever the hell you want to. Seriously. I want to see somebody call this side happy face. All right. So what do they tell me in Mathish using what we've determined here? What's the equation from what they tell me? 2x plus 2y equals 40. Crazy. Which I can make into this. Is this cool? Amazing. What do they ask me in Mathish? Yeah, so they ask me about the area. So what's the area? XY. All right, we're going to do this problem without calculus, and then we'll do it again with calculus, just because. So this is what it would have looked like back in... these first three steps are the same. What do I do from here? And again, you've heard me say this before. What's wrong with this? What's kind of wrong with this equation? Two damn many variables, right? So I can use what they tell me in what they ask me. Now let's see who remembers this. Oh yeah, that's right. This is beautiful. Sorry. Who remembers how to do this in pre-calc? I don't want any calculus. How do I find the maximum of that? I mean, what is that? What shape would that take on? That function. If I graphed it, it would be what? Parabola. I don't need calculus to find that max. Because the maximum's just the vertex, right? And this thing's opening down. That's why it makes sense it's a vertex. So now we know shit like, well, it's concave down. Well, that's where the first derivative is 0, right? But you did this problem before you knew any calculus, even if you forgot. So how do I, you guys remember the shortcut to find the vertex? X equals negative b 2a. I'm gonna show you where that comes from using calculus now in just a minute. Let's just finish. Does that sound familiar to anybody? Familiar? Okay. What's b? 20. Good. And what's a? Negative 1. And you've been so patient. We're finally catching up to you. So if x is 10, that means that y is 10, which means the area is 100. So that's my maximum area when it's 10 by 10. Okay, I like it. Now, when is the answer not going to be a square? Well, if I said I was going to build something next to a river, I always love this. Or next to my house is better. Here's my house. My house has seen rough times. If I build something next to my house, I only need 3 sides, correct? Yeah, I'll make those X for you guys. Then it's not going to be a square, obviously. Or maybe not obviously, but oh well, okay. All right, we'll see those kind of problems. Real quick, about this. If I have this, how do I analyze this calculus-wise to figure out its max or min? What would I do? Take the derivative. What's the derivative? And then I would set it equal to 0. And don't I get minus b over 2a? Holy shit! I have no idea if or how your instructor showed you where negative b over 2a came from back in the day. But that's a beautiful, now that you know calculus, a lot of stuff you've done before is easier.
Can you explain what B and A represent?
Just the coefficient of x is b and the coefficient of x squared is a. That's all. So up here, that's why I knew that b was 20 and a was -1.
Okay.
Is that cool?
Yeah.
So this is the general form. So coefficient of x squared, coefficient of x. I like it. Real quick, by the way, I can't stop myself. What's this here? And what does it find? Finds the intercepts. Where's the vertex if I know the intercepts? Isn't it exactly in the middle of the intercepts? Well, isn't this negative b over 2a plus or minus stuff? Do you guys agree with me? You guys understand? Are you allowed to do this on your no? But do you understand what I'm saying? So isn't negative b over 2a plus stuff minus stuff? That finds the intercept. So isn't negative b over 2a right in the frickin' middle of the vertices of the intercepts? That's how I show where the negative b over 2a comes from without calculus. But with calculus, it's like bam. You know, it's kind of nice. Okay. All right, enough of that. If I were to do, the only thing I would do differently if I were to do this problem with calculus is right here, I want to maximize this function, correct? So what would I do? Take its derivative. Set it equals 0. Do you guys see how that gets to x equals 10? Okay. Now, some of you guys might say, well, the other way we just did it was about just as quick, Jeff. But will all of our functions end up being quadratic? No, they're not going to. In fact, most of our functions are going to be something far funkier. So that's the power of calculus. Pre-calc, you have to have a parabola. Anything else, you're screwed. Or you have to do it on your calculator, right? Calculus, we can handle anything, man. It's all just derivatives. Okay. It's all just derivatives. All right, so let me give you this. All right, so I made something a little more interesting. It is still a rectangular space, but the answer is not going to be a square because it involves a little bit extra stuff. So go ahead and, well, let's see. Let's all agree on something. Draw it. Okay. Label the sides. So what do you guys want to use? Anybody want to use something different?
Smiley face, frowny face. I like that.
I kind of want to, but let's not. It's a little bit much to try to keep track of right now.
Yeah, L and W.
L and W, okay. And whenever we say that, I always think A and W, and then I want some frickin' root beer and a frickin' hamburger. All right. Write expression for the area as a function of length and width. Okay, so the area is, incredibly enough, length times width. Okay, now, read through part B. Okay. Does it matter? What do you guys think? Does it matter which side we say costs $15? Like, does it matter if that's an L or a W? No, because the math doesn't give a shit what we call things. It's just going to give me the answer, whatever. Okay. So can we all agree on how to do this? Which side do you want to cost $15? W. Okay. So let me kind of finish this picture out a little bit. What will the cost function be then? if we're saying that W costs 15 and then the other three cost 10. So you can imagine maybe this one side costs more because it's where you have to install gates to open or something. I don't know. You guys kind of with me? Or maybe it's a different type of material. I don't have a clue. All right. I don't know real life. Are you kidding me? I'm a math teacher. I don't know. I could tell you how the physics behind an engine. I can't fix anything in it. Okay. That's good, Jeff. Good job with your life. Shut up. So how do I write the cost function then? Total. Yeah, it'll be, so I got, let's kind of build it up. I got 15 times W, right? And then I've got 10W, 10L, 10L. So I got 15W plus 10W plus 20L. Is that cool so far? And then, of course, I've got 25W. That is a W, okay, plus 20L. So that is my cost function. All right, now, I should have put this up here, but that's too bad for me. Given that the area is to be 20 square yards, so now that we know our area is to be 20, and here's our cost function. So it's the same old thing. This is going to happen more often in these problems. I think some of you guys, and I should have made this clearer, when we did this kind of thing earlier, the tell me, ask me, I kind of cleared it up later, but it didn't mean like every problem was going to be that multi-step. In this section, a lot more of them are going to be a multi-step problem. Yes?
Don't we have to adjust for it being 20 square yards instead of square feet?
Yes. Why did I do that? Oh, I never mean to do that.
60 square.
Yeah, so let's make it, so that's a good catch. Past Jeff was really feeling evil. So my units don't match. I can't remember if any of the Homer problems do that to you. That might be why I did it here. I can't remember. So yeah, this is 20 square yards. Now here's where you got to be really careful. 20 square yards is not 60 square feet. 20 yards is 60 yards. 60 feet, sorry. 20 square yards, you got to multiply by 3 twice. Once for each yard, right? So isn't yard squared yard times yard?
Yeah.
So you multiply by 3 to make the 1 yard to feet, multiply by another 3 to make the 1 yard to another feet, then you get feet squared. Ooh! So I'm almost certain there must be a Homer problem that's got weird units. And that's why I put it down here. So thanks for catching that. So how many total feet is square feet? 180. Okay. And again, just to really make sure everybody understands, this was in feet, this is in yards squared, so we got to make the match. I could have went the other way, but that would have made these numbers really gross. So normally I'd rather make my bigger unit broken down because that's multiplication instead of smaller units made up is division. And that could lead to fractions, which, hey, I'm really good at math, but if I can choose an option that has no fractions, I will do that, right? Because that's just one more place humans make mistakes. Okay, let me stop for a minute. I didn't really want that much to be in this, but oh well, there it is. So here's my cost function. What is the same problem with the cost function we had before? What is the problem with the cost function? The same problem we had before. Too many variables, right? So what can I do here? I pretty much tell you, solve the area function for length. Replace the length in the cost function. So this will be length equals 180 over W, right? Use what they tell us in what they ask us. So now I can write this as 25W plus 20 times 180 over W. So now I've got a cost as a function of width. So let's kind of do a little bit here. Become a thing here. So this would have been something you would have to do in the calculator back in pre-calc. And I know you still could, but too bad for us, we know how to do it by hand now. So how am I going to find the dimensions that minimize this cost? Of course, what am I going to do? Take a derivative, yeah. So C prime, help me out here, what's the derivative of this with respect to W? Let me do this really with respect to W. There we go. This is where some of you guys understandably will have trouble. This is not a related rates question. There's no information about, this thing isn't growing or shrinking or something. It's just a set. There's no change over time. I want to know how the width affects the cost. So I'm doing derivative of the cost with respect to width. So if I change the width, how would the cost change? Does that make? I know this is one of the hardest things about this class is we learn sometimes you got to do d by dt, and then everything's frickin' chain rule. This is not that situation. This is not rates of change. This thing isn't like breathing or something. That would be really freaky. What is that fence doing over there? So what do I get?
25 minus 3600 over W.
Good. So this is 3600 W to the -1. -1 would come down. Now it's to the second power, right? To the -2. I like it. And then I want to make that equal 0. What is the, what's one critical number? If the width is 0. If the width is 0, what's our area? 0, right? It's just I just would put the fence in a big line. So I don't have any area. You guys with me? But that is a critical number, isn't it? Because it makes that undefined, but of course that's bullshit. That's the part I don't give a shit about. So of course I'm going to set this thing equal to 0. All right, solve that. Oh, I see what you did, Jeff. Okay, this will come out nice. It's kind of weird. After you've been teaching for a while, you have this backlog of worksheets you made like years ago. So I don't know when I made this thing, to be honest. This is like old as hell. So now I'm like, young Jeff, what were you thinking? All right. All right, let me do this step by step. Don't you get something nice? Yeah. Officially you get plus or minus 12, but we know we're not in Math 90 anymore. We don't think that a shed could be negative 12 feet long or something. I love that. So the width is 12 feet. What would the length be? Is everybody cool with the 12, by the way? I'm sorry. Right, you guys all see that? If the width is 12, what's the length? Well, we got a function of, we got L as a function of W right up there. 180 divided by W. So it's whatever 180 divided by 12 is, roughly. 15? Ooh, look at that. Is that a square? What do you think? No. Okay. I was kind of
square.
All right. I will show you where the square is. There is a square here. Okay. Stay with me. Oh God. Is everybody semi-cool with this? Is this really that horrible?
How did you get 12?
Are you cool with this here? So I would add that over, multiply by W squared, divide by 25. Is that cool?
Yeah.
And then this divided by this is 144, yes?
Yeah.
And then square root.
Oh,
Yeah.
okay. That's W squared better.
All right. Now let me see if I can get you guys to agree with me. Real quick, I'm sorry. Let me draw this. Let me do something we didn't do. I'm going to draw the cost. Are you with me? So this will be 10L, 10L, 10W, and this is the special side. Are you guys cool with that? What did we figure out the length was? 15? So isn't this side going to cost us $150? And so will this side. Yes? And this side costs me 150. I'm sorry. Yeah, 150. No, the width was 12. There it is. 120. And what's this side going to cost me? 15 times
15 times
12.
I thought that one was 15.
Sorry?
It is.
And isn't this 180? So what's the total cost here?
300.
300. What's the total cost here? 300. Sorry.
So there is a
There sort of is a square. Yeah.
Oh, okay.
Now, do you have to know any of that shit? Where the hidden square? No. Right? Yes. Are you good? Okay. Anyway, I kind of like that they still sneak in. Even if it's not a square, it sort of is. Oh, yeah, I do have another one. Any questions on that one? And again, I'm sorry, everything in red here, you do not have to understand. And you're like, why couldn't you write anything else in red, Jeff? But hopefully, this isn't that horrible, I hope. I hope. You know it's going to get worse, though, right? But still, so far, not too bad. All right, so this question, real quick, they would give me a function, like here's x squared minus 1. Let me just draw this like there, barf. That's a gross sketch, but that's fine, because I didn't have to draw a sketch. I just did because I want to, so it can look like whatever I want it to. And the point 2, negative 1. So it's going to be about like right here. And the question would ask me this. This would actually be the question. This is all they would say. Find the point on that function that is closest to this point. Do you guys agree with me that it looks like it's going to be like straight across from it like that? Right? Okay, I like it. So what do I want to minimize? The distance between 2, negative 1 and a point on that function. What is this point? What is the answer? I love you. I don't want numbers. What point is this?
X squared minus 1.
Is everybody cool with that? Right? That's any point on the graph. I like it. And the point 2, negative 1. So can you write, and I do this for a reason. What is the distance formula? You guys remember distance equals the, no, I love you guys, not dirt, not rate times time. The distance between 2 points. The square root, big ass square root. x2 minus x1 squared plus y2 minus y1. Can you imagine calculus, derivatives? You want a big ass square root over a bunch of shit? Wouldn't that be a chain rule?
Yeah.
If I minimize the squared distance, doesn't that minimize the distance? This is kind of cool. I really want you to understand. So if I wanted to use the actual distance formula, it would so suck because there's a square root, the shit's inside, chain rule, oh my God. So we just realize, oh, if I minimize the squared distance, I don't need to look at d, I just need to look at d squared. And this will be, somebody help me out. x2 minus x1. Yeah, because it'd be x squared minus 1 minus negative 1. Yes, maybe? So my squared distance is x minus 2 squared plus x squared squared, which is x to the 4th. And then how do I minimize that? Take a derivative, set it equal to 0. It's not going to be undefined because this is a beautiful polynomial, right? You could multiply this out if you want to. Do you see why that would be silly? How do I do this derivative? In fact, here's how you write it for one thing. You could square this out, couldn't you? I don't know why you would, because what's this guy's derivative? Beautiful. Plus? So I want that to be 0, right? So I get 2x minus 4 plus 4x cubed equals 0. Holy bejesus, Jeff. What were you thinking? I wonder if this works. Okay, this is neat. All right, let me ask you guys this. First thing I could do is divide by 2. Is that cool? What's wrong with well, what's wrong with that is I didn't divide by 2. What's wrong with this? Why is this not going to be easy?
Well, one, you didn't write it right.
Oh, of course. Thank you. Thank you for telling me so nicely. Now, what's wrong with this? What's the one thing that's not right to be able to just do this directly if it would do what I want to do with this?
Cubic.
It's cubed. Shit. Right? Does anyone know what to try to do? Because what am I going to try to do with this? I want to try to factor it because it's equal to 0. So if I can factor it, what could we try? Does anyone know what we could try to do to factor this?
Put the 2 on the other side and take an x out.
No.
Yeah.
That would be to set it up for guess and check. Would sort of be what that is. Anybody?
Root everything to the 3rd degree.
Oh no. Because you couldn't do each piece. You can't distribute a cube root across minus and plus. You could do synthetic division. Synthetic division is what helps you factor things that were previously unfactorable. Do you guys remember doing, oh geez, we're not going to finish this today, by the way. Do you guys remember how do you get the list of all possible rational roots? Maybe this is why I did this. You guys, does this sound familiar at all? Wouldn't it be all the factors of this divided by all the factors of this? Does that sound familiar to anybody? So that would be 1, 2, 1/2, plus or minus. Then I would try to synthetically divide. I'm really curious if this is factorable past Jeff. What were you thinking about? Alternately, since it's such a short little thing, you just plug a 1 in. You could plug a 2 in. See if you get anything that works. It doesn't look like... I don't think anything's going to work. This was gross, Jeff. So maybe this is one that you would have to do in your graphing calculator. What do you think? Yeah, I don't see any nice way out of this. Do you guys, I don't know if you guys are with me at all, but I want to try to factor this. If that was a squared, I could maybe do it. If it was a squared, even if I can't factor it, I could use quadratic formula, right? There is actually a cubic formula that somebody named Cardano found, and he was a guy that was involved in duels, and he took a lot of drugs, and the history of math does sometimes get very interesting. He poisoned somebody trying to steal some of their mathematical results from them. Anyway, so he was a little interesting. But what I would try to do is to try to synthetically divide. You could do it, Jeff.
Why are we plugging in negative 1?
Just to pick one of these. I don't know. Yeah, I don't see this going anywhere. Or alternately, I could try to plug each one of these. So I do believe, I don't know if I'm pretty sure that this is one you'd have to get from your calculator, which kind of defeats everything, but I won't. Okay. And what does that mean, by the way? What does that mean by get this from the calculator? What would you do to get this answer from your calculator? Let's get this answer before we head out. Anybody know how to answer that in your calculator? Aw. You're not mine, are you? No. Anybody? Everybody is always like, why can't I use my calculator? Go ahead. I don't know how to use my calculator. Okay. So what I would do is I would put this in. Just so we all end up, if you're playing along with me, I would hit zoom 6 just to get a nice standard window. There we go. And it looks like it's right there. Is it 1? Does 1 really work? 2 plus 1 minus, no, it doesn't. So it's got to be, then I can find the 0, pleasantly called 0. Does this, let's see if this looks, I'm pretty sure I did something like this earlier. You want a left bound, you want the right bound, and you want to put the cursor on the answer. Yeah, so I get 0.835. So Pashchef really made a horrible problem. That's too bad for all of us.
Find the 0.
Yeah, we're finding the 0. So it's roughly 0.835. So that looks to be, so this point would look to be about 0.835, comma, whatever. So then you would plug 0.835 in here to figure out the y piece of that point. All right, so I didn't mean for that one to be quite that gross, but there will be several problems in the homework that says find the closest, you find this minimum distance between this function and this point. I think there's at least one, if not two. And hopefully they're not quite as bad. All right, that's enough. So don't forget, quiz next time, first thing. And our test is coming up, if I remember correctly, isn't it?
25th?
25th?
Week
Is it?
after, right?
Yeah, okay, not
Yeah.
too soon, not too
Yeah.
soon. All right, I got too many classes in my brain. Yes?
My calculator not grabbing.